Hello everyone, my name is Kwan. Today we will explore some of the property of the physics body. We start with the new projects and we choose game. We choose any file number. Here just choose S7. Once you create SpriteKit comes with the pre-built game. Let's run it. So we haven't done anything yet. This comes directly from the SpriteKit. As you can see, we have Hello World. If we click on the screen, you can see the rotating airplane here. This one does not have physics yet, so we're going to apply some physics to this plane here. This is basically the original code when we create a SpriteKit games. When we click it, you see a rotating plane. Now we start apply the physics body. So to apply it on the sprite here, on the plane, we say sprite.PhysicsBody equal sk PhysicsBody, and we make the circle of radius equal by half the size of the width of this plane. So we run it. So when you clear, you see the airplane start falling down. And the reason is every time you apply physics body, there's a gravity, it's falling down. If you don't want the airplane to fall like this, you can add a property like physics body affected by gravity equal force. So if you run it, the plane will not falling because of this command here, physics body affected by gravity equal force. By default it's true. So once you apply the physics body, there's gravity, then that make the plane falling down. If you don't want it, then you put in physical body affected by gravity equal force. That's why the plane will not fall. I just add in this command here. Basically, if the location is 300, then we create a space shift. If the location is larger than 300, we create a circle. And we give the physics for both of location. Okay, so run it. If I click down here, you see that falling because we give physical body. Same thing on up here. If you don't want to make the plane falling down, then we put this command in, physical body affected by gravity. Now the other way that we can make the ball just drop it by making physical not dynamic. Okay, so we can put this command sprite physics body dynamic equal force. Right now it's true, that's why it's falling. So take out this command and run it. Now if you click down here, the ball will stay there. Now if you click down here, the plane will drop. And it's to interact with the ball. So depend on what angle is falling to the circle, it might fall this side or that side. So the ball is not moving because we put it sprite physical body dynamic equal force. On the game view controller Swift, I just simplify the code there, and I create a scene as view bound here. So when I return to game scene, I put this command in, physical body physics loop edge rect. So when I do that, and when I click, you see that the airplane will not go out of bound because we restrict the physics body to the edge loop from rect. equal view frame. I just add some of the code to create those blue ball here. Here I have a loop and I create 10 ball and I create a pad and I use the context to draw a CT pad at arc. I give the radius of this blue circle is 30 and I give the physics body of those blue ball, and the position of those ball initially is random, so if I run it, you see it's random there. So I still able to put the red ball here and the airplane dropping down. I do again. Just for fun, I just add this logic in to give the ball a number, so you can see that 0 to wherever. One thing that you pay attention here is that after I create my label, I call the ball, okay? Say the ball at the child label. So wherever the ball go, the label follow it. So the label is the child of the ball. Here I just for fun I create a random generator, yeah? And I add to this ball. So I run it. So every time I click, I get the new color. As you can see here, if I push it here, create a new ball, it does make room for those balls. I just bring in the moon image in as an image access, and on game scene, change this one to moon, run it. So far we have not been explored the mass of this ball, so we are gonna start adding the mass difference between the blue and the moon here. So let's say add right down here, say sprite, physical body, mass. Let's say I say 5, control R to rerun. So the moon should be much heavier than the blue ball, okay? So if I start from, you can see that here I put into 5. So if let's say I put 35, that's very heavy. So if I put down here, so just let's say I just put in a very small number, let's say 0.5. I think the default is 0.13 pi. So let's try. I just add a few lines of code here. So every time I drop the ball, the mass will be random from 1 to 20. And I put the label, the red label here, that's the mass number. succeed. So I'm gonna drop the moon, and this moon has a mass of 7. I can drop the ball. So you can see that mass of 12 is much heavier as it dropped down to ground. Mass of 7 again. See, if the small number does not create a lot of motion, so it's a big number, it can create a lot of. Do again. 3, 2, very small number. 6, very big number. Here I'm testing out the property, okay, called PhysicsBody restitution. See how bouncy the ball is. If I drop down here, see the ball very high. So it does not lose a lot of energy when it drops. Let me do again. If I reduce this number to, let's say 0.3, so it does not bounce much, you can see. Here we want to test the friction. Here we set to 0.5. If you notice that the blue ball is not rotating, okay, the reason is that I just put this command in called ball physical body allow rotation false, right? So if I take this one out, by default it can rotate, but if you don't want it to rotate, then you put this command in. You can see that it spin around. So the number spin around the blue ball. I just add a couple things here. First, I make the radius of the ball is random, and secondly, the color is random also. If you notice that the moon there, sometimes it rotates one side, sometimes it rotates the other side, because I just change, put this equation on angle here, right down here, for this angle. So you see that some rotate clockwise and the other one counterclockwise. I just add in the logic here, so the ball can rotate too. See that the ball rotate, and the direction is random. I just add in this command to make the sure the moon, the size of the moon is relative to its mass. Like 18 is very big here, 6 is very small, 19 is even bigger. Similarly, I do for the ball. So if I run it, so the mass is relative to the size of the moon. See you in the next video.